Hi everyone, I am Vanita. I am doing BE in Electronics and Communication Engineering in SVCE Bangalore. I am from Honda section. Today my subject is mathematics and the topic is Gauss Seidel method and eigenvalues and eigenvectors. Gauss Seidel method. Introduction. Iterative methods such as the Jacobi method or the Gauss Seidel method are used to find a solution to a linear system with variables x1, x2 till x1 by beginning with an initial guess at the solution and then repeatedly substituting values for x1, x2 till x1, xn into the equations of the system to obtain new values. The methods are successful if the values for x1, x2 till xn are eventually stabilized, thereby producing the actual solution. Before applying the Jacobi method or the Gauss-Seidel method, the equations are rearranged so that in the ith equation, the coefficient of the xi is non-zero and so that xi is expressed in the terms of the other variables. In each iteration of the Jacobi method, the most recently obtained values for x1, x2 till xn are substituted into every equation in the system simultaneously to obtain the next set of values for x1, x2 till xn. The Gauss-Seidel method differs from the Jacobi method in that immediately after a new xi value is obtained from the ith equation, it is used in place of the old value in successive substitutions. The Gauss-Seidel method generally takes fewer steps to stabilize, but there are linear systems for which the Jacobi method is superior. Iterative methods are often effective on sparse matrices. Other advantage of iterative methods is that round of errors are not compounded. Let us see problems on Gauss-Seidel method. 20x plus y minus 2x is equals to 17. 3x plus 20y minus z is equals to minus 18. 2x minus 3y plus 20x is equals to 25. 20x is equals to 17 minus 5 plus 2z. X is equals to 1 by 20 of 17 minus y plus 2z. Equation 1. Y is equals to 1 by 20 minus 18 minus 3x plus z is equals to equation 2. Z is equals to 1 by 20 of 25 minus 2x plus 3y. Equation 3. Let us do first iteration by taking x is equals to 0, y is equals to 0 and z is equals to 0. X raised to 0 is equals to 1 by 20 of 17, that is equals to 0.85. Y raised to 0 is equals to 1 divided by 20 of minus 18 minus 3 of 0.85 plus 0, that is equals to minus 1.027. Z raised to 0 is equals to 1 by 20 of 25 minus 2 of 0.85 plus 3 of minus 1.027 is equals to 1.01. Let us do second iteration. X raised to 1 is equals to 1 by 20 of 17 minus of minus 1.027 plus 2 of 1.01 is equals to 1.002. Y raised to 1 is equals to 1 by 20 of minus 18 minus 3 of 1.002 plus 1.01, that is equals to minus 0.999. Z raised to 1 is equals to 1 by 20 of 25 minus 2 of 1.002 plus 3 of minus 0.999 is equals to 0.949. Third iteration. X raised to 2 is equals to 1 by 20 of 17 minus 0.999 plus 2 of 0.999, that is equals to 0.999. Y raised to 2 is equals to 1 by 20 of minus 18 minus 3 of 0.999 plus 0.999 is equals to minus 0.999. Z raised to 2 is equals to 1 by 20 of 25 minus 2 of 0.999 plus 3 of minus 0.999 is equals to 1.000. Fourth iteration. X raised to 3 is equals to 1 by 20 of 17 minus of minus 0.99 plus 2 of 1.00 is equals to 0.999. X raised to 3 is equals to 1 by 20 of minus 18 minus 3 of 0.99 plus 1.00 is equals to minus 0.999. Z raised to 3 is equals to 1 by 20 of 25 minus 2 of 0.999 plus 3 of minus 0.999 is equals to 1.00. Here, third iteration and fourth iteration are get similar. Thus, x is equals to 1, y is equals to minus 1 and z is equals to 1 is the required solution. Let us move on to the eigenvalues and eigenvectors. Introduction. Eigenvalues are associated with eigenvectors in linear algebra. Both terms are used in the analysis of linear transformations. Eigenvalues are the special set of scalar values that is associated with the set of linear equations, most probably in the matrix equations. The eigenvectors are also termed as characteristic roots. It is a non-zero vector that can be changed at most by its scalar factor after the application of linear transformations, and the corresponding factor which scales the eigenvectors is called an eigenvalue. Definition. Eigenvalue definition. Eigenvalues are the special set of scalars associated with the system of linear equations. It is mostly used to matrix equations. Eigen is a German word that means proper or characteristics. Therefore, the term eigenvalue can be termed as characteristic value, characteristic root, proper value, or latent root as well. In simple words, the eigenvalue is a scalar that is used to transform the eigenvector. The basic equation is Ax is equals to lambda x. The number or scalar value lambda is an eigenvalue of A. Let us see problems on eigenvalues and eigenvectors by using power method. Find the eigenvector and the corresponding eigenvector of the matrix by using power method. Given 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. By taking the initial vector as 1, 0, 0 to the power 3 to the power t, perform 4 iterations. Solution. Ax to the power 0 is equals to the given matrix into transpose of the initial vector 1, 0, 0 is equals to, by multiplying the given vector and the transpose of the vector, 6 minus 2 is the required solution, that is equals to, by taking the highest value in the required solution, 6 outside, and dividing the 6 divided by minus 2 and the 2, we get 1 minus 0.33, 0.33 is equals to x raised to lambda raised to 0 and x raised to 0. Ax raised to 1, 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 into the required solution of the first iteration, 1 minus 0.33, 0.33 is equals to, by multiplying the second iteration matrix and the given iteration matrix, we get 1 minus 0.45, 0.45. Moving on to third iteration, Ax to the power 2 is equals to the given matrix into 1 minus 0.45, 0.45 is equals to 7.8 minus 3.8, 3.8 is equals to, by taking the highest value outside and dividing that by the matrix 1 minus 0.48, 0.48, that is equals to lambda of 2 into x raised to 2. Ax to the power 3 is equals to the given matrix into 1 minus 0.48, 0.48 is equals to 7.92 minus 3.92, 3.92 is equals to 7.92 into 1 minus 0.49, 0.49 is equals to x raised to 3, lambda raised to 3 and x raised to 3. The largest eigenvalue is 7.92 and the corresponding eigenvector is 1 minus 0.49, 0.49 is the required solution. Thank you for watching.